everyone, this is Mrs. Bokerman. This video is going to teach you Unit 8 trigonometry, all about the angle of depression. So you should have already watched the video about angle of elevation, so it's very similar, except we're going to talk about the angle of depression. Once again, you need to know the three main trig functions. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Because after you draw your picture, you really have to decide based on what information you're given, should you use sine, should you use cosine, or should you use tangent? So angle of depression is actually the angle between the horizontal and your line of sight when you're looking down. So the angle of elevation, as you can see in this picture, is the angle where it's looking up, and the angle of depression is actually outside your triangle. It's actually the angle looking down. Okay. It's very important to certain professionals, and we use it every time we look at something when we're looking down. Pilots use it when they're trying to land planes, people in watchtowers, a bird swooping down. There's just some examples of what the angle of depression is. Okay, so let's get started. I'm going to do 5 examples with you. So we have an airplane at an altitude of 1,200 meters. The angle of depression to the base of a building is 28 degrees. So we want to know how far is the plane from the building. So the hardest part, again, for anything is to take that information and draw a picture. So I would start with a triangle, and then I would start with a plane up top. So you know that the distance is 1,200. And then the angle looking down is 28 degrees. So here's the picture that I got. I have this plane going straight across. I know that it's 1,200 feet in the air. It's looking down at the building at 28 degrees. And we want to know how far away this building is. Okay, so really we're going to use right triangle trig. We're going to use our SOHCAHTOA, but I have a side length and a side length. I need some angle in here. So if you recall from geometry, alternate interior angles, I have this angle, parallel lines, cut by a transversal. So if this angle is 28 degrees, that means this angle here is also 28 degrees. Okay. Now that I have my angles, I can now decide what trig function I'm going to use. Okay. So if I have this angle, this is what I'm looking at, then I have the across, I have the opposite, and I have the adjacent. So opposite and adjacent make tangent. So then I'm going to set up my equation. I know that the tangent of 28 is equal to the opposite 1,200 over x. Now that I have that, I just have to solve it. So to get x by itself, whenever you have division, I'm going to multiply this x up. So then I have this, and I'm trying to get x alone, so the opposite of multiplying is to divide. So essentially what happens is this x and the tangent of 28 just kind of switch spots. Okay. Now here's where on your calculator, you want to make sure you're in degrees. So if you have a graphing calculator, make sure you hit mode. And then if you scroll down, make sure it's highlighted on degree and not radian, because we do everything in degrees. So then I'm going to just switch it over and divide, and I'm going to end up with an answer of 2,256.9 something something. We're going to round to 1 decimal place with the nearest tenth, because that's how your Math Excel assignment is going to be. And that's your answer. That's how far away the plane is from the building. So let's try another one. A sonar operator on a battleship detects a submarine, so below it. The distance between the two horizontally is 500 meters, and there's an angle of depression of 37. So we want to know how deep is the submarine in the water. So if you let that digest, this is the picture I came up with. You have this battleship up here. It's detecting a sub. We want to know how far down is that submarine. The angle of depression to the sub is 37, and the distance between them is they're 500 feet apart. Similarly, like the last problem, I can automatically say that this is going to be 37 degrees. Okay, so I know that that's going to be the same. And now I'm going to look at this angle. So if I'm looking at this angle, I want to know across, opposite, and I have the adjacent. This is a hypotenuse because it's always your right triangle. So again, I'm going to use tangent. So I'm going to set it up. Now this one's actually easier to solve than the last one, because if I want to get x by itself, the only thing I have to do is multiply 500 up. So if I multiply 500 up, then I have this. X is already by itself. So now I'm just straight typing this in my calculator. 500 times tangent of 37 is 37.6.8 meters. Okay. And make sure you use 1 decimal place with your rounding. Moving sidewalks take zoo visitors down a hill. The sidewalk drops 48 feet. Its angle of depression is 15. How long is the sidewalk? So this one's a little different. Okay, so you have a sidewalk going down the hill, and the hill is 48 feet. So this is what kind of it looks like. You have this sidewalk, or I made it an escalator, but it's going down a hill, and you want to know how long that is. It has a drop of 48 feet, and the angle of depression is 15. So again, if that's 15, alternate interior angles, this is going to be 15. Okay. But this is where I want to use a different trig function. Okay. So I have the opposite, but I don't have, I'm trying to find the hypotenuse. So opposite of hypotenuse is actually going to be sine. So I'm going to do the sine of 15 equals 48 over x. Opposite hypotenuse. I'm trying to figure out how long this is. So I'm going to multiply the x up, but I'm trying to get it by itself. So again, these two essentially are just going to switch spots. And I'm left with, move this out of the way, the sine of 48 divided by sine of 15, which gives me 185.5 feet. So it really depends. Sometimes you're going to use tangent, sometimes you're going to use sine, sometimes you're going to use cosine. You got to look at what you have. All right, I got two more examples for you. Similar to the last one, a truck drives down a 25-meter decline. So now we know how long the hypotenuse is. The angle of depression is 21 degrees. How high was the truck above ground level? So this is the picture I came up with. We know that the truck drove 25 feet down, but we want to know how far up was it from the ground originally. And this angle was 21 degrees. So again, this is going to be our angle down here. We're going to put it into the triangle. We know that this is 21, alternate interior angles. So let's assess which one we should use, sine, cosine, or tangent. If here's our angle, then we know we want to figure out opposite, and we have the hypotenuse. So we're going to, again, use sine. So I'm going to say the sine of 21 is equal to x over 25, opposite over hypotenuse. I'm going to multiply the 25 up to get x. X is by itself, so I'm just going to type that into my calculator, and I get 8.9 meters. And again, your units just depend on if it's meters, miles, feet, whatever it is. And we're always going to use one decimal place, unless otherwise noted. All right, the last one is a little bit different. I did want to give you one example where instead you're given two of the side lengths and you're actually trying to find the angle of depression. So Tristan is attempting to dive from an 8-foot tall diving board into an inner tube that's 12 feet from the base. So what should his angle of depression be to ensure that when he dives, he hits the tube? So this one looks like this. We have this guy. He's going to jump into this tube. It's 8 feet up from the water, and the tube is 12 feet away. So now you have both sides, but you're trying to find this angle so that you know this angle, the angle of depression. So this is 12 and 8. So if I want to know this angle, I have the opposite and I have the adjacent. So I'm going to use tangent. So the tangent of x is 8 over 12. So this is where, remember, before we were trying to find just angles, you actually have to use the inverse trig. So on a graphing calculator, you have to hit second and then tangent. So if you do that, second and then tangent, you'll type in 8 divided by 12, and it should tell you the degrees. We want 33.7 degrees. So it's not that much harder. It's just you have to remember when you're trying to find the angle, you need to do inverse tangent. Okay, very similar to the problems of elevation. The only difference is all these problems, the angle's on the outside of the triangle, so you need to put the angle on the inside. Okay, the next thing you should do is practice, 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 and then try your homework. Good luck.